Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 7 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is sponsoring this series of video lessons, and in these lessons we will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Now, believe me, your life and my life are going to be a lot easier if we are working on identical hardware. And so if you don't have your gear already, look down in the description. There is a link over to Amazon where you can pick up your own Sunfounder kit. But enough of this shameless advertising. Let's jump in and talk about what I am going to teach you today. And today's lesson is really a follow-on to lesson number 6, where we learned all about pull-up resistors and pull-down resistors and how to get input from something like a switch or a push button. Now, I told you this is a topic that usually people just skim over, and I really wanted to make sure that you understood it. So in lesson number 6, we actually went in and we built the circuit, putting in the pull-up resistor or putting in the pull-down resistor, and then connecting it up to the power supply or connected to the 3.3 volts for the pull-up resistor or connecting it to the ground for the pull-down resistor. And so hopefully by doing that, you really understand pull-up and pull-down resistors. Now, since you understand it, today I'm going to show you an easier way to do it. Okay, there is an easier way to do it, but if I would have just jumped in and shown you this, I don't think you would have really understood it. So let's go back and let's see. I should probably give you a view of the studio here. I always like to show you guys the studio. Just show you that I'm keeping this thing clean, and we're going to be working today a little bit on the graphics tablet, and then also you're going to be getting a live view of my build over here, and of course I've got my nice coffee. Okay, so let's see if we can come over here now to the sketch pad. Let's see if we can get that to come up. I think it's going to take me just a second here. Seems like I always have the wrong cable in there, and so let's see if we can fire the sketch pad up now. There it is. Okay, so now let's go back and let's review, and it always seems like the sketch pad wants to disappear for a second once we call it up. Okay, let's go back and review what we learned last week. And what we had done is we had connected to pin 40, the GPIO pin 40 lower right on the Raspberry Pi, and then we'd come out and then we had put a pull-up resistor, which was a 10K ohm or 10,000 ohm resistor. We'd come up to the 3.3 volts, which is pin 1, and remember, don't hook it to 5 volts, you have to hook it to 3.3 volts, or you will what? You will fry your Pi. And then we put the little push button switch over here like this, and then the push button switch went to ground. And just to review how that worked, if nothing is going on, if the switch is open, if the button hasn't been pressed, then no current can flow. And since no current flows, the pin 40 directly sees the 3.3 volts, and so as it's just sitting there, it will read that as a 1. Now, if we close the switch, then pin 40 directly sees ground, and we read a 0. And again, it's a 0 because once the switch is closed, then the current can flow through the resistor down to the ground, and all the voltage drops across this 10K resistor. Okay, so we can read a 1 if the button is up, and we read a 0 if the button is down. That should make sense. This is just reviewing what we did last week. Okay, but now here is the new thing that I am going to teach you today. Let me get rid of some of this earlier stuff. Okay, so this is what I'm going to show you. This resistor, this pull-up resistor in this connection to 3.3 volts can be done internally. It can be done inside the Raspberry Pi. There is a command that we can give that will automatically put in a suitable resistor inside the Raspberry Pi and hook it to the 3.3 volts. What does that mean? That means we just need the switch, and the switch would be connected where? To the pin 40 or whatever our input pin was, and then the other end to ground, and then we activate the pull-up resistor inside the Raspberry Pi. Kind of crazy, isn't it? Bet you're saying, why didn't you just show us that the first time? Because I wanted you to really understand it. So let's go in and let's see where we left off last week. We left off with this circuit, and we have this schematic up here. And again, what you can see in the schematic up at the top, that we have that 10K resistor at the very left of the picture, and then it is connected to pin 1. That was that 3.3 volts. And then we go into the switch, and then the left of the button, the left of the switch, is also hooked to pin 40, which was our input pin. Well, yeah, it still needs to be hooked to pin 40, but what we don't need is anymore, we don't need the resistor, and we don't need that wire to 3.3 volts. And so what we got to do is just yank those things out, and we just end up with this schematic. So I can take the yellow wire out that was going to the 3.3 volts, and I can take out the 10K pull-up resistor. Okay, and so now we have a much simpler circuit. All right, what do we do? Do we just toss these aside? No, we very carefully put them back in their proper spot in the SunFounder kit. And I don't want to slow you guys down by doing that, but just know you need to keep your kit organized. Okay, so now we have the switch. The left of the switch is hooked to our GPIO input pin, which is pin 40. The right of the switch is hooked to ground. And then over here we have just our good old-fashioned LED circuit, where I believe we are using pin 38, GPIO pin 38 on the long leg of the LED. And then on the short leg of the LED, we go through our 330 ohm current limiting resistor. And then the right leg of the resistor, we come back to ground. And I think that ground was in fact, pin 34. Okay, so we're using pin 40 as a GPIO input pin, pin 38 as a GPIO output pin, and then we're using 34 as the ground. And so that should be the circuit, and hopefully you guys still have that set up. Hopefully you guys still have that set up from last week. And all you got to do is just yank out that resistor and yank out that wire to 3.3 volts. But if we're going to do that, we've got to now go in and we've got to do the code in a way that activates that internal pull-up resistor. And so let me see how to get over here to the correct view. I think this would be the right view. Okay, you can see the Raspberry Pi there, and then I'll kind of do a little rearranging here where you can also see now, you can also see the circuit. Okay, so if we're going to do this now, what we're going to need to do is we're going to need to fire up a terminal. And let me take just a second to make sure that you see my terminal properly. I want to make sure that you see everything that I'm doing. Okay, I think that looks good. And now I am going to come over here and I'm going to need to make a new program. So I'm going to say nano, and I'm going to nano what? Python, down into that Python folder. Let's look and make sure that that's there. Yep, you see the Python folder there. So I'm going to nano down into Python, and I'm going to create a new program, and I'm just going to call it internal pull up like that .py. All right, now I do need to do one little thing here. Okay, I think I've got that. I've got like I say, I've got a lot of Windows management here I have to do as I'm showing you this stuff. Okay, so now what we want to do is we want to go in and we want to do that push button, press the button down, turn the LED on, let the button off, the LED goes off. And so how are we going to do that? Well, still, like last time, we are going to have to say from time import sleep, because we're going to want to slow this thing down a little bit. We don't want it to run too fast. We're also going to need to import RP little I, uppercase RP little I, GPIO, and then we import that as GPIO. You could import it however you want, but GPIO is pretty descriptive. I'm going to put a delay. I'm going to define a delay, and let's make our delay like 0.1. Just slow it down a little bit, 0.1 seconds. Now, what was our in pin? Our in pin was 40, GPIO pin 40, and our out pin that controls the LED, that was going to be pin 38. Okay, and now we need to tell the Raspberry Pi what numbering scheme we are going to use on the pin. So it will be GPIO, because that's what we named the library, and then set mode, because that's the method we're using, and then GPIO.what.board. That uses the physical pin numbering system. Now what we need to do is we need to set up that output pin, GPIO.setup, and then it's going to be what the out pin, and the out pin is going to be a what GPIO.out. All right, now this line of code is where the magic happens, and that is our GPIO.setup. And what do we want to set up? The in pin, like that, the in pin, and then what is that going to be? GPIO.in, as you might expect, right? But now the hidden parameter, the magic parameter, and that is pull up down, all lowercase, pull up down. So that's saying we're going to put in either a pull-up resistor or a pull-down resistor. We're going to put the resistor and we're going to connect it inside the Raspberry Pi. Because we took it out of the board, we got to now do it inside the Raspberry Pi. And what that's going to be equal to is GPIO dot what? Pull up down, PUD, pull up down, all uppercase, and we're going to make it a what? An up, like that. We're going to make it an up, like that. Okay, so now what that's doing is inside of the Raspberry Pi, it is putting a pull-up resistor between 3.3 volts and GPIO pin 40. Is that right? Yeah, 40 is our in pin. Okay, now what we can do is we've got those set up. So remember, we want to do our cleanup. So we're going to do this whole thing inside of a try and except. Okay, and if that doesn't make sense, go back and watch last week's lesson. Now we're going to create a continuous loop, just while true. When's true? True. True is always true, so this will be an infinite loop. And then we're just going to read the value coming off of GPIO.input, and we're going to read the what? The in pin, like that. And so now what are we going to have? We are going to have a 1 if the button is not pressed, and when we press the button, it's going to be a 0. Okay, and so then what I can say is if, and what, let's just go ahead and print it. So I will say print read val, so we can see what's going on. Then what I can say is if read val equal, if read val equal 1, that means that nothing has been pressed. And so what I want if nothing is pressed is GPIO.output, okay, to the out pin. And what I want to output to the out pin is 0. I want it to be off because I haven't pressed the button. Now similarly, if read val equal 0, which means the button has been pressed, then what do I want to do? I want to GPIO.output. What do I want to output to? The out pin. And what do I want to output? A 1. All right. And so that all looks good. Now I just need to clean up. So I say if you get a keyboard interrupt, so the except is on keyboard interrupt, What does that mean? That means the interrupt is Control C. So it's going to just keep trying. It's going to just keep looping in that while loop under try until what? Until it gets the keyboard interrupt, the Control C. And then when it gets the Control C, it's going to hop down here. And I'm going to do a GPIO.clean up like that to release those GPIO pins. And just to see that I actually did release the pins, I'll say GPIO ready to go, meaning that it has been cleaned up. GPIO ready to go. All right. Could it really be that easy? I hope so. Let's go Control X. Yes. Enter. Now what we're going to do is we're going to see if we can Python 3 that. All right. Python 3. Hold your breath. Oh, line 70. Oh, you got to spell except right. Okay. Did you guys see that? I think I did that last week too, didn't I? Did I do that last week as well? Except. Okay. Like that. Okay, and you guys can see all the code there in case any of that was behind my head. You can see what we're doing. I try to not get in front of the code. I really do. Okay. Now, we might get an error this time. Why might we get an error? Because we started the pins and then we crashed the program before we cleaned the pins up. And so let's just see. Oops, wrong one. Python 3. Okay, line 18, GPIO.cleanup. Ah, man, I'm doing some terrible mistakes here, aren't I? Okay, had an extra colon there that didn't belong. Okay, take that out. Control X, yes, enter. Now really hold your breath this time. Okay, it's doing a read, but I see one thing right off the bat I don't like. So I'm going to Control C out of there, GPIO ready to go. I forgot to put my delay in, so it was going too fast. So let's come back here and let's nano it. And after we do the two if statements, let's just put a sleep. And how long do we want to sleep for the delay, which we set at 1/10 of a second. Control X, yes, enter. And now we go up. And then we go up, Python 3, hold your breath. Okay, that's looking good. Now, all eyes on the LED, all eyes on the LED. Boom! Look at that, Shazam. Okay, now why is this like, well, this is what you did last week. No, what I did last week is I showed you how to understand the concept between pull up and pull down resistors. And then this week, what did we do? We learned how to use the pull up resistor that's built into the Raspberry Pi so that you don't have to build it into a circuit. So now if you want to use a switch, or a push button in your circuit on your Raspberry Pi, all you have to do is have a wire to your GPIO pin and a wire to your ground, and then in your code activate that pull-up resistor when you are doing the pin setup. Does that make sense? Okay, guys, this has been a quick lesson and a fun lesson, and man, I hope you guys don't get mad at me because I spent so much time on this concept, but just as I see the comments people make, they talk about pull-up resistors, but they really don't understand it. And the key concept is that you cannot have a GPIO pin floating and try to do a read from it, because if you do that, you might read a 1 or you might read a 0. Okay, guys, now it's time for your homework, okay? And this is kind of really a very interesting homework problem. And the reason the homework problem is so interesting is because it sounds so simple. And in fact, it is so simple. It sounds simple and it is very simple. But the problem is it turns out to be like a really mind-boggling hard problem. And so what I will tell you is there is a very, very simple solution, and that simple solution takes about 10 lines of code. It's really, really simple. Okay, I'm just going to go up and I'm going to look. I'm going to count the number of codes, the number of lines of code, so that I'm not lying to you. Okay, so that I'm not lying to you. So let me look at it up here real quick. I'm not going to show it to you, of course, but because I want you to figure it out. Okay, I have got, 23 lines of code. 23 lines of code to do this. So it's not a long program to do this. But let me come back here and let me show you what your assignment is. Control C, and I left cleanly, and I'm going to run Python 3, and then I'm going to run Python down into toggle.py. Okay, so here is what your assignment is. All right, now watch this. Same circuit, all right, same circuit, same using an internal pull-up resistor, but I'm going to run this, okay, saying a 1, meaning the button's not pressed, but now watch this, okay. I press the button, and what happens? The LED comes on, and what? Stays on. Now I press it again, and the LED, what? It goes off, and it stays off. Come in, press it, it comes on, press it, it goes off. Now watch this. I'm going to press and hold. I'm pressing and holding, and then voila, it comes on. Or I press and hold, and I let off. Okay, and so you see, what do I have? A toggle switch. Now why is this important, and why am I putting you through this torture? The reason we are doing this is because, like, imagine that this were a real light bulb, or imagine this were a motor, or imagine this was whatever. You would not want to sit there with your finger on it to keep it held on, right? What you want to do is you want to toggle it on and then toggle it off. This is a toggle switch, okay? And so this is the homework assignment. And you guys use your existing circuit and write the code to create a toggle switch. Now, I will say kind of the two classic problems that I see students having the most problem with is, one is the classic sort problem, where like you have a list of grades and then you put them in either ascending or descending order, and people just struggle mightily with that. And the other one that people struggle with is the toggle switch. So what I need you guys to do is do your toggle switch. Post your solution to YouTube. When you post your solution to YouTube, leave a link back to this lesson so anybody that is watching your video will have context and kind of know what you're trying to do. Also, leave a comment down below if you're able to do this. I am Uber Legend. Yes, you get the coveted Uber Legend title if you're able to do this toggle switch this time. Then also, when you post your solution to YouTube, down in the comments below, give a link over to your solution, because I actually go in and I look at every single homework solution that you guys post. I like to kind of see what you're doing, and I like to see how you are doing it. Okay, guys, I hope you're having as much fun with these lessons as I am. I hope you have a lot of fun with this homework. I hope a few of you guys actually figure it out. And don't go in and try to Google it and find the solution. Just see if you can do it on your own. Because what I'll tell you is, this is not a coding problem. This is not a Python program. This is not a programming problem. This is a thinking problem. You have to think through it. And when you think through it, you'll get it on paper where it works. And then you know what? If it works on paper, it will be very easy to get it working in the code. Like I said, mine was 23 lines of code, and most of that was just the up top setup type of stuff. Okay, guys. As always, I want to give a shout out to all you who are helping me out over at Patreon. It is your support and your encouragement that's keeping this great content coming. You guys that are not helping on Patreon, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. If you like the video, be sure to give us a thumbs up. If you have not subscribed already to the channel, make sure that you subscribe. When you do, ring that bell so you will get notification of future lessons. Also, make sure that you share this on social media. See if you can get your friends working on this, because the world needs more people coding and doing engineering, and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.